good stuff on there. Next problem. 12. Oh. A lot quieter now. Let's see. Okay, in the school cafeteria, students choose their lunch from 3 sandwiches, 3 soups, 4 salads, 2 drinks. How many different lunches are possible for a student who chooses exactly one of each? One of each. So, how many ways can he choose a sandwich? So there's 3 ways he can choose a sandwich, right? And how many ways are there to choose soup? Yeah, times 3 ways to choose a soup, times 4 for the salad, and times 2 for the drink. That's it. 3 times 3 times 4 times 2. That's 72. Yeah, permutations, combinations, that kind of stuff. This is all about probability. And you just remember that every choice you get multiplies things by the number of choices. So, you know, if there's 1,000 choices out there, and then you say, well, I can do those 1,000 in red, or I can do those 1,000 in blue. Well, now you just doubled and said there's 1,000 red and 1,000 blue. That's 2. So you multiply by the number of choices, blue or red. That's 2 times 1,000. 2,000. All right. 38. Oh, that's one of my favorites right there. I love the pill shape. I do that in my class. And the pill shape. It's a rectangle inside of a circle that's been split. In the figure below, points E and F. This is 38. Oh, I just dropped my finger. I had a student put this up here, and he's hung on all year until I just now knocked him off. Come on. Now I'll never get him back. Nope. Yeah, he's a little green heart. All right, so in the figure below, points E and F are the midpoints of sides AD and BC of the rectangle, blah, blah, blah. Point G is the intersection. Okay, let's just go. What's the ratio of the area of that to the area of the shaded region? So basically, I want to find this area here. If I find that area, and then I find the whole area, the total, I can subtract them to find all the shaded regions. Rather than working and trying to find each of the shaded regions, if I find this one area and the total area, I can subtract it. I mean, I got to find the total anyway, so let's see. Now, what do we know? E and F are midpoints. That's a mid. That's a mid, okay. G is the intersection of AF and BE. Okay. H is the intersection of CE and DF. Okay. The interior of ABCD, except for the interior of EFGH, is shaded. What is the area? Okay, so the question is, how do I figure out what's going on here? Well, I know if that's a midpoint, this and this have to be the same. And since it's a rectangle, I know the top and the bottom are the same. So this and this also have to be the same. So now the question is, do I have congruent gray triangles? Well, this side has to be the same as this side because it's a rectangle once again. And all these corners have to be 90-degree corners. So do all these gray triangles look like they are congruent? Well, I've got side, angle, side on each one of them. They each one have a 1 mark, a 90-degree angle, and a 2 mark. So that tells me they are all congruent to each other. Since they are all congruent to each other, I know that all of these sides are also congruent to each other. And that means that side and this side are congruent. And this angle is congruent to this angle. So this means I have an isosceles. Let me use a different color here. I've got an isosceles triangle down here. So this side has to be congruent to that side. So when I remove that, when I remove these pieces, take them out, then the remainders also have to be congruent to each other. And I could do that same argument for the other side. So really, what have I found out? What kind of shape is this? It's a rhombus. It's a slanted square, right? But I could also see it as two isosceles triangles. Okay? Now, this is the same as these two here. These are vertical angles, which tells me that that triangle and this triangle are the same. All of this gets down to the idea that that is going to be the midpoint of this half of the circle. So this will be like the 1/4 way through the circle. This will be like the rectangle. So if this is like 0, then this is a 1/4, a half. I can do the same argument over here, and this is going to be 3/4, and that's going to be a whole. Doing all of this just to find this area in the middle. This area in the middle is kind of being a booger. So now I'm going to erase all this, and I'm just going to put back what we knew. We know that we've got 1/4 of the way, 1/2 the way, 3/4 of the way, and the whole way. That being said, we know that the width of this shape is the same as half of the width of the whole shape. How do I know that? Well, because it goes from 1/4 to 3/4. Going from 25 to 75, that's like 50 cents. That's like half of it, right? So this is going to be half of the original shape. I know that the height of this is going to be the same as the original shape. So if I call this H, and I call this length here W, then the area of the whole thing, the area of the big rectangle, is going to be H times W, right? Now, what's the area of the rhombus in the middle? Well, it's two triangles, right? So I could say if I want to cut it, it doesn't matter which way I cut it. Let's say I cut it down this way right here. Then it's going to be H tall. The base is going to be H. And the width of this thing is now going to be 1/4 of W. So the area of the left triangle is going to be H times 1/4 W. So the area of one triangle is going to be, now the formula is 1/2 base times height, right? So it's going to be 1/2. The base was going to be H. The height was going to be 1/4 W. Multiply that all together, and I'm going to get 1/8 of WH, or HW, whatever you want to call it. But there are two times an eighth WH, because there's two of these shapes. So it's really 1/4 WH. So the area of the total is WH, and the area of the rhombus is 1/4 WH. So how much is the area of the gray? The area of the shade is 3/4 WH. But now let's look at what the question is. The question is, what's the area of the shade, the EGFH, the rhombus, to the shaded? So now put a ratio together, 1/4 WH over 3/4 WH. The W's are going to go away, the H's are going to go away. And it basically, the fourths are going to go away. And it's 1 to 3. 1 to 3. And that's a beast of a problem. I wasn't sure I was going to get through that thing. And I'm a geometry teacher, right? But if you just keep hitting it, I didn't really know where I was going to start off with, guys. I just started, I don't know every problem when I look at it. I just start throwing things up there and saying, well, what's going on here? What can I say about this? What can I do? And then eventually something clicks and I go, well, there we go. There is a way to prove. The question is, do I know that the area of 1 and the area of 2, do I know that they are the same? There is a way to prove they will be the same, but it's not something that most people know. But yes, there is a way to prove they will be the same. Actually, if you just do this, you can kind of intuitively see that all of the triangles are going to be congruent. Let's see. Did we actually prove that the areas were the same on them? We proved that the big triangles were the same. Take away their, you'd have to take away where they overlap. It comes back to that same problem. You can make that assumption, you get to the right answer, but you still jump to the conclusion that these two would be the same area. So without proving it, I mean, it's not a solid proof, but if that intuition gets you the right answer on the question, on the test, then go with it. Exactly. It might have been something where, you had to look at it and say, you know what, maybe these are all for the same area, and this will be 1 out of 4. Now, I'll show you the easy way to prove that they are the same area. It's like this. What's the formula for a triangle area? 1/2 base times height. Here, let's call this the base, and let's call this whole thing height. So this is going to be 1/2 of the height, and this will be 1/2 base. So when you multiply 1/2 height times base and 1/2 base times height, see you guys, you get the same. So that's how you could prove that they are all the same area triangles. All right, were there other problems that we had to do here? Let's see. 40. What is the surface area in square inches of an 8-inch cube? All right, so surface area is going to be the sum of all the areas. I don't really have to draw it out. I could do two things here. I could either, one, draw out that there's going to be one face. It's going to be 8 inches by 8 inches. But there's 6 of those to make a cube. Boom. 8 times 8 times 6. Is that going to be 384 or something? All right. And was that 40? All right, we're caught up. So, was there any questions on the science packet that anybody wanted to work? I'm going to go ahead and stop this one since the next one is science.